Am I live now? Oh, I'm live. Okay. I'm gonna go ahead and start sharing my screen. All right, so we are live, and hey, what's going on? I just want to go ahead and talk a little bit about this thing I'm doing here. This is a live stream. I usually do this every day, about maybe 10-20 minutes. The idea is to kind of, focus on learning something new, and the idea is to kind of review like all of the streams of math and try to get through it within, like, I don't know, I'm thinking like 3 to 6 months to go from like arithmetics to algebra and calculus and beyond. And the idea is to just, pay attention to it. So I use my iPad and the stylus to stream my iPad through this, through my Zoom account online, through my desktop, and, just go through it. And my idea is to kind of like in real time record everything, whether I do well or I don't do well, and just talk through it and try to give myself basically an opportunity to work better in public, and also to, to kind of record certain things, so that's basically what it is. So let's jump into it. So we have here, it is multiplying decimals at 4 times 0.6 standard algorithm. All right, so I'm not too sure what that was, but I'm going to continue doing it the way I did it before and see how that works for me. So I have like here, I always go to 1.0, and you have 0.5, and this is very similar to, multiplying like 1 times 75, where you would get 75, right? But because we have we have 2 digits, with 2 digits, we have, how I basically say this, we have, we're 2 digits behind the decimal point. So we have 2 digits, we have 2 decimal points, we're 2 decimal places. So that would mean if I times 1 times 0.75, you go 1, 2 here, because with the 2 pieces over here like that, and you should be able to see that, there's 75. Move on. Next one. All right, so next is the, we have 9 times 8. Well, 0.8. No, so let's go ahead and say 9 times 8. It's pretty much 72. So 9 times 0.8 is pretty much 1 decimal point. And it should be 7.72, right? Because this over here, let's just grab that, we'll move it over here like that. And we will add 0. And kind of like that. So we can go ahead. There we go. Now we can move on to the next one. Now this is the same one we had before. I'm going to bring it up real quick. So if we have 1 times 0 times 75 like this is equal to 0.75, then over here we will have a 10 times, let me put a 0 here, put a 0 here, 75. We know we're going to have a 75 down here somewhere, but we're going to have extra zeros. So since we have an extra 0 here, probably going to have an extra 0 over here. And, and it's not going to be, it's actually going to be like this. So we get an extra 0. So that's my intuition. So because of the fact that 1 times 75, 0.75 is 0.75, 10 times 0.75, the 0 goes back here because the fact that we're timesing it by that. So let's go ahead and see how that works. Let's be like that. Oh, this doesn't work. So that basically shows us what to do in first right now. So let's go ahead and do the multiplication then. Okay, so the multiplication here, the multiplication here would be very similar. 0.0, point here, and 75 like that. So what we do first, we add another 0 just to do it. So we'll say, like we have on here, it says 0.5 times 0. So 0.5 times 0 is equal to 0. That's for this one. And then we have 0.5 times this 0 here. 0.5 times 0, 0 equals 0. And we have 0.5 times 10 is equal to, well, go back to 5, 5, 10 would be 50. So this is 10, that extra 10 would probably make it 5. Oh, I think I got an idea now. Yeah, what in the wrong direction? So there we go. So now we can go ahead and we put in this 1, and then we like 0.8 is very similar to 1 times 8, which equal 8. So since we have this 0.8 here, we know we're going to go back here. Anything times itself is true, but to remember, I want to remember the idea of as this is a small number, and it's getting smaller and smaller and smaller as we go along. So let's go ahead now and we put in times 7. And okay, what did I do now? Okay, so you have 7 times 7 is equal to 49. So we have 0.7 times 7 is equal to, move that up like that. Oh, made a mistake again. I wrote it right, but I didn't write it in yet. All right, so we have the other one here where we're going to put 0 to 5 and times it by 6. So let's go ahead and look at this. We have, it's probably going to be a little bit more difficult to go ahead and do it with, we just have 1 times 2. We know that 1 times 0.25 is 0.25, but so we have is 1 times 0.26. We're going to have to do the multiplication. Let's do the multiplication real quick. Okay, so we have 0.25. We have here, and then you have 30. This is 12, 15. This 0, and plus 1. So that's basically it. So we're behind 2 decimals, 1, 2. So if you look at it from here, it's just like this. 1, 2, 3, 4, 5, 6. It's 1. And that's 2. No, yeah, that's 0.5. So it's good to do that. It's good. You have 1.50. Move on to the next one. All right, so next one we have is, you have 2 times 0.6. And I want to just, say 6 times 2 is 12. So, but we know, I want to actually do the drill. So the drill basically means we would 6 times 2 is equal to 12. So 2 times 6 would be 12 as well, but we would move it here 1 decimal point because we have 1 decimal point here. This is multiplication. Sorry if that confuses anybody. So we have that, we put this over here, and move on to the next one. All right. So now let's move on to the next one. So we have here 0.2 times 2. I don't want to skip it because I know what the answer is. So just bear with me. So we have here 6 and 2 is basically the same one we had before, where we have 6 times 0.2 is equal to, it's just like saying 6 times 2 is equal to 12, but we move it 1 decimal point. I hope that's not confusing. Now I realize how confusing it is. With 1, it's 2. Move on to the next one. Now this is great. It's a very even number because it's like 4 quarters equals $1. So we could just say, 24 times 4 is equal to 25. Yeah, it's equal to 25 to 1. All right, and we have 3 times 5. This is pretty much 3 times 50 cents. So we have 50 cents here, and then we have maybe $1.50. And then we can have this one where it's 8 times 6. It's just like having our 8 times 6, 56. Oh, I'm sorry, it's 48. 48. Because it's just like saying 8 times 3 is 24. And 24 is 48. 48. 8 times 6 is 4.28. Now we have this one where we say 0.2 is times 4. And just like saying, let me do it. Like 4 times 2 is 8. And then we have this point here. So we add the point there as well. So 0.8. Let's move on to the next one. This is just like saying 9 times 6. So that's basically just like say 9 times 6 is 54, right? So if you have the little, so 9 times 0.06 is, you say 54, but to move the decimal point up here. The decimal point is back here. Move it over there. So it's still 0. And I like looking at it like that. Okay. And I'm gonna just drop that, and what I'm gonna do is that since I'm actually pretty good with the multiplication piece right now, I'm going to end this and finish it up. That way you don't have to worry, keep watching it. And I have 5 more minutes. Let me just finish with 5 more minutes. Okay, so because it's actually 2, you can just always do this, or we can go ahead and do this, which will basically be the same thing. And then we go back 2 decimal points. So let's put that there. We can do the same thing for this one. 23 is times 9, and that's 27. 18 is 20, and then that's 11, and 2 decimal points, 11.7. Or we can say, we can just put, this, which would take a long time, but we want to do this if we, so 2, 4, 6, 8, 10. Yeah, so it's basically this. If you add up all these things here, it should be 11.7. So this is 27, this is 9, 18, 19, 20, 29, 9, 10, 11. Yep, 11.07. Okay, now you have here where we go 9.49, and you have 9.49 times 2. And then that's, this is basically 18, 5. And then here's 18 again. It's 1858. Or we can just say 949 times here. We can get the same thing. So 1848. No. 1858. Whoops. That was my bad right there. Okay. Oh, wow. I'm actually really, really wrong. What did I do wrong? Oh, yeah, I see what I did right there. And that's some of the things that I'm realizing as I'm this is 8, 9. Whoops. And put that out there like that. Now we have 4.9 times 3. And you have 4.9 times 3. Let's do this. Like that. All right, and I think this will be the last one. So let's just do the math just because we haven't done it in a while. So I put the dot here as a multiplication. So there's 0 times 9, and then we have 0 times 4.0, and we have 3.0 times 9, and then we have 3.0 times 4.0. And now we say 9 times 0 is 0. 9 times 4.0 times 0 is 0. 9 times 3.0 is 2.0. And then we have 4.0 times 3.0 is 12.0. And then we will add up these zeros. These zeros will lead to 0. This is 7, this is 9, add a point there, and then there's 3. So 7, 8, 9, 3, 2, 3. Is that right? Only one way to find out. All right, so that brings us, now I'm a little bit thrown off because I don't remember the 49. So it's like, to make these easy for me, I'm just like 12 to 14. Yeah. So I did something wrong here. Definitely 4.7, 14.7 then. And the reason why, and see, that's great. I was able to use that to correct myself because I know that, you know, this is 4.9. So that means that, you know, the nearest one is 5, you know? So it's 5 times 3, it has to be at least 15. This is way bigger. So my math, even though I made a mistake with my mathematics right here, I can go up here and check my work to avoid getting a problem, basically messing up my on the problem itself. So we have here 1.47 times 3.90. All right, then we go ahead and we can just, I will go ahead and do this because this will help me to, you know, pay attention to certain pieces. So you have 9 times 7 times 9 times 40 times 9 times 100. And then we have 330 times 7. I think that's where I went wrong last time. And we have 30 times 40. And then we have 30 times 100. So now we can go ahead and do the math over here. To make it easy for me, I'm going to just bring it down here and do the math. So 9 times 7, 63. Then we have, let me make sure I make it large and easy to do the math underneath it, because I think 63, and then we have 9 times 40. Well, 9 times 4 is 36, so 9 times 40 has to be like 360. And then you have 9 times 100 is 900. And then we have 30 times 7 is 20, yeah, like that. 30 times 40 is a bigger number like that. So that's 1,200. And then we have 30 times 100. Since we know 3 times 100 is 300, 30 times 100 is 3,000. So now we can just add that up. 1, 2, so I don't get confused. So we have here 3, and then we have here 6, 12, 13, 13, and we have 9, 12, 27, 28, 29, 30, 102. And then you have here 6, 7. So you have 72 times 7,233. 7,233. All right, so let me go ahead and erase this. I'm gonna grab this whole thing. And just for simplistic sake, I'm gonna do that. And since we know that, since we have that idea, and we have 7,233, we have we're behind 2 decimal places. We go 1, 2. So it's from 72, 33. No. Maybe it's, oh, it's one more. I like that answer. No, I'm actually wrong now. So wrong. All right, so 3, 4, 5, 6. So now what did I do? Let's check it out. $5,733. I was 3, 4. Oh, I think I added it in the wrong spot. Yeah, that was close. I should have actually noticed that that was too much. That was too high. But it's okay. We all make mistakes. So, yeah. We all make mistakes. All right, so we have here 2, 3, 6.0. So to make sure I remember that, so we know that 6 times 2 is 12. So then we know that 6 times 2.3 has to be greater then 12. So what we can do first is, I'll just go ahead and start doing the math. We have 0 times 0.3, which is 0. And then we have 6 times 2.0 is 12.0. Make sure we know these at zeros underneath there. Maybe I should even do something like this to help me to, like that. And then we have, and that's it. Oh, that's weird. Because I do 0, 0 like that. And then we do 6 times, oh, I see what happened. Then I'm missing one more. So you have 6 times 6.0 times 6.0 times 0.3, like that. And that will leave us with, because I can think of 6 times 3 is 18. But we know, since we have this 0.3 here, that we're going to do something like this. So then we have 13.8. Like that whole thing, like my intuition about other things helped me to step up the other pieces that I was missing. So I'm running behind time. I wasn't supposed to be this long. All right, so we have here 0, 0, 0. I'm gonna fall back to my old way just to finish this right now. Well, you know what? That's not good to do that. Let's not do that. All right. So what we're gonna do is we're gonna solve this the other way, knowing that we have this answer here. We can say 6 times 5 is 30. We have 6 times 24 is 24. Oh no, let's do it. Let's do it the other way. 6 times 40 is 240. 6 times 2 is 6 times 200 is 1200. And then we have 3 times 30. 30 times 5 would be 150. And we have 30 times 40 would be 1200. And then we have 30 times 200 is 600. And you have the 0 here, and then you have 7, 8, 9, 10, 11, 12. 12. You have 3 plus 3 is 6. 6 plus 6 is 12. 12 plus 2 is 14. 1, making sure. So it's 3,420. And because that's not the actual answer, I'm going to just type it in because I'm out of time. No, I did that totally wrong. It's 30 times 200. Yeah, that's where I probably went wrong. It's this last one's 30 times 200, which is not 600. 30 times 200 is 6,000. Yeah. So let's just go here. 6,000. Then you have 6,000, and then you have 6, 7, 8, 9. So 6, 7, 8. And that would basically be 8. So now we know that that's 8,820. We will go to 2, 3. Okay. And there we go. So, and indeed, as you get like more and more of the problems, it gets, you got to slow down doing what you're trying to do. But I think I'm actually going to work on one more problem, division problem tomorrow. And then after that, then I'll start doing the decimal, dividing the decimals. And hopefully we'll be able to start, you know, the algebra parts next week, which is pretty much a very simple thing. I think I'll probably do the mastery challenge first to get an understanding on what I already know. And then instead of reworking on every single thing, probably just work on what I know, when I'm having problems with, and see if that may help to expedite this. Because you don't have to go through the whole thing the way I'm doing it, but I'm doing it because I like to practice, you know, learning different ways of moving numbers around in my mind. And if you should do that, you know, as well, when you're trying to, you know, like learn something new. The reason why I'm doing all this is because I want to start working on more advanced stuff, such as like um, differential calculus, differential equations. There's also like linear algebra that I don't know if they talk about it in here. Oh, they do. Linear algebra. I don't see the courses. Let me see if I can edit them and just check to see. Do you have, yeah. So they don't bring up linear algebra. It's just this. Linear algebra is a form of algebra. It's just a different type of it. I want to do it because I want to understand a little bit about something called matrix factorization. It's a concept of mathematics where you utilize an algorithm to help wage like what people use. It can use it for like Netflix, you know, for example, uses it to figure out what people may want to watch or what most people are interested in, you know, and recommendation engines are usually built upon those particular ideas. So I'm really excited to try to play around with those things. But in order for me to really get there, I think that gamifying this whole entire access of learning is important. And if I can do it in such a way that I'm able to build upon the things I've learned before, like I just recently learned, I probably will do much better than trying to just relay the things I learned, you know, 10, 20 years ago, you know. So thanks a lot, and I'll see you guys in the next video.